This is a multiple-choice question testing your understanding of the method in. I'll assess your knowledge of how this method works. Get ready to select all true statements. This sets the stage. We are using a Gaussian process classifier from the sklearn library for a binary, two-class, classification task. You've already trained the model. Now, it's time to evaluate how well it's performing using the method. Let's carefully examine each statement to see if it accurately describes the behavior of this method. This statement describes the output format. The method will give you an array. Each row represents a single data point that you want to classify. Each column within that row will give the probability of that data point belonging to a particular class. For example, in a binary classification problem, you will have two columns for each data point: the probability of belonging to class 0 and the probability of belonging to class 1. Here, I am focusing on the meaning of probabilities. The probabilities provided by always add up to 1 for each data point. This is because they represent a probability distribution. The total probability of all possible outcomes, all classes, is always 100%, or 1. This statement is about whether the method works for binary classification. This is incorrect. Works perfectly well for both binary and multi-class classification tasks. It will provide probabilities for each class regardless of whether you have two classes or more than two. This statement is about dealing with imbalanced data. Even if the classes in my training data are imbalanced, meaning one class has many more examples than another, the method will still return a probability for each class. The probabilities might not be perfectly balanced, but it still gives probabilities for all classes. I am testing your understanding of the method. This explains the goal of the question. I want to know if you really grasp how the method behaves. I'm checking that you understand its output, how it handles binary versus multi-class problems, and how it deals with situations where the training data has unequal representation of each class. I see that this refers to the input data you'd use to train your Gaussian process classifier model. This data would include features and corresponding class labels that the algorithm will learn from. Think of it as the ingredients for your machine learning recipe. This refers to the output your model produces after training and running _predict_proba_. Specifically, you'll get an array of probabilities. Each row in the array represents a single data point, and each column will contain the probability that the data point belongs to a particular class. It's like getting the prediction scores for your machine learning recipe. I'm focusing on the _predict_proba method within the Gaussian process classifier. This method is crucial because it gives us probability estimates, not just hard classifications. It helps us understand the model's confidence in its predictions. Think of it like this: instead of just saying, yes, or no, it tells you, I'm 80% sure it's a yes. This is a multiple-choice quiz to test your understanding of the _predict_proba method's behavior. We'll analyze each statement to see if it accurately reflects how this method works. I understand that you are using the Gaussian process classifier from the sklearn library to perform binary classification, meaning you are trying to categorize data into two groups, like yes, no, or spam, not spam. After training your model, you are now assessing its performance using the _predict_proba method, and we have to analyze some statements about its behavior. This statement says the output of _predict_proba is a table, a multi-dimensional array. Each row represents one data point from your dataset, and each column represents the probability that data point belongs to a particular class. For a binary classification problem, you'll have two columns. One for each class, e.g., probability of class 0 and probability of class 1. This statement tells us that if you add up the probabilities for all classes for a single data point, the total will always be 1, or 100%. This makes sense, as it represents a complete probability distribution for that data point. This statement is incorrect, as I will show you. The _predict_proba method works perfectly well for both binary and multi-class classification problems. It adapts its output to the number of classes. This is correct, even if your training data has an unequal number of samples in each class, an imbalanced dataset, predict underscore proba, still returns a probability for every class for each data point. The probabilities might be biased because of the imbalance, but it will still provide estimates for every class. The correct statements are A, B, and D. These correctly describe the behavior and output of the predict underscore proba method in the Gaussian process classifier . Statement C is incorrect because the predict underscore proba method works for both binary and multi-class classification problems, contrary to what this statement claims. This refers to a specific method, predictproba, within the gaussianprocessClassifier, which is a tool from a machine learning library called sklearn. It's used to get the predicted probabilities. I use this method to determine how confident my classifier is in its predictions. This indicates that I am facing a multiple-choice question about the method mentioned above. This is the core question. I need to assess the accuracy of various claims about how predictproba behaves. This statement says that the output is structured as a table. Each row shows the prediction probabilities for one data point, and each column shows the probability of the data point belonging to a certain category. I'm checking if that's correct. This statement claims that all probabilities for a single data point will always add up to 100%. This is standard in probability theory. It is the property of a probability distribution. I check if this is true for this specific method. This statement says that predictproba only works with more than two categories and will fail if you only have two categories, binary. I need to verify this. This statement checks whether the method gives probabilities for every class, even if I have more examples of one class than the others in my training data. I need to see if that's accurate. I'll explain the predict underscore proba method in the scikit-learn Gaussian process classifier. This method gives you the probability that a data point belongs to each class in your classification problem. It's a key tool for understanding your model's confidence in its predictions. This is a multiple-choice question testing your understanding of the predict underscore proba method. You'll be presented with several statements about how this method works, and I'll help you determine which are correct. Get ready. This sets the stage. We are using a specific type of classifier, a Gaussian process classifier from the scikit-learn library, sklearn, for a binary classification task, meaning only two possible outcomes. The question focuses on the predict underscore proba method, which estimates probabilities. We need to figure out which statements accurately describe what the method does. This statement is correct. The output of predict underscore proba is an array. Each row in this array represents a single data point from your dataset, and each column gives the probability of that data point belonging to a particular class. For example, if you have two classes, each row will have two probabilities that add up to 1. This statement is also correct. Because predict underscore proba gives probabilities, and probabilities must sum to 1, the sum of probabilities for each data point across all classes will always be exactly 1. This is a fundamental property of probability distributions. This is incorrect. The predict underscore proba method works perfectly fine for both binary and multi-class classification problems. It adapts its output based on the number of classes in your problem. There will be no error in a binary classification case. This statement is true. Even if your training data has a significantly uneven number of data points for each class, imbalanced classes, predict underscore proba will still return a probability for each class. The output will still reflect model's uncertainty for each class. These are the answer choices. Based on our analysis of the statements above, we can determine which are correct and which are incorrect. This is the final step in the quiz. This is a multiple-choice question testing your understanding of the predict underscore proba method within the scikit-learn library's Gaussian process classifier. I'll guide you through each option. This sets the scene. We're using a Gaussian process classifier, GPC, a machine learning model, for a binary, two-class classification problem. We want to understand how the `predict_proba_ method works in this context. The question asks you to identify the true statements about `predict_proba_ from given options. This statement is correct. The `predict_proba_ method outputs a table, array, of probabilities. Each row in the table represents a single data point from the dataset, and each column shows the probability that the point belongs to each class. For example, in a binary classification problem, each row will have two columns, one for the probability of belonging to class 0 and another for the probability of belonging to class 1. This is also correct. The probabilities are normalized. They always add up to 1 for each data point. Think of it like this. The total probability of a data point belonging to any of the classes must be 100%. This is incorrect. `predict_proba_ works perfectly fine with binary classification problems. It just means that instead of multiple columns representing many classes, there will only be two columns, one for each class. Absolutely true. Even if one class is significantly more frequent than others in the training data, `predict_proba_ still outputs a probability estimate for each class. The estimates might be skewed, but the method still computes a probability for each. This is simply a heading referring to the concept that each data point is assigned probabilities across classes. This tells us that the output of `predict_proba_ is an array. An array is just a structured way to organize the probabilities. Each row in the array represents a single data point and each column represents a class, as I explained previously. This further clarifies the structure of the output array. The probabilities are arranged so that each column represents a specific class, and each row is for a specific data point within your dataset. I'm focusing on the method within the GaussianProcessClassifier. This method is all about predicting class probabilities. It gives you a numerical estimate of how likely each data point is to belong to each class. Think of it like this. If you're trying to classify emails as spam or not spam, we'll tell you the probability that a given email is spam and the probability that it's not. It's super useful for understanding not just the classification but also the model's confidence in that classification. It's like getting a second opinion. This question challenges you to test your knowledge of the method. You need to pick out the statements that accurately describe how it behaves and what it returns. We'll examine each statement carefully to see if it's a true reflection of the method's behavior. It's a bit of a detective game. I'm going to explain this. The method returns an array of probabilities. Each row in this array represents one data point, like one email in our spam example. And each column represents a class, spam or not spam. The numbers in each row represent the probability that the data point belongs to each class. So, if you have two classes, each row will have two numbers adding up to 1. For example, a row might look like 0.8, 0.2, meaning an 80% chance of being spam and a 20% chance of not being spam. I'll break this down for you. Since the numbers in each row represent probabilities, and the data point must belong to one of the classes, these probabilities will always add up to 1, or 100%. It's a basic probability rule. The total probability across all possible outcomes, classes, must equal 1. In our email example, the probability of spam plus probability of not spam equals 1. Let me clear this up. This is incorrect. The method works perfectly well for both binary, 2 classes, and multi-class, more than 2 classes, problems. The only difference is the number of columns in the output array. 2 columns for binary and more than 2 for multi-class. It's adaptable. I want you to understand this. Even if your training data has a lot more examples of one class than another, like much more spam than not spam, we'll still give you probability estimates for each class. The probabilities might be skewed because of the imbalance, but you'll still get a probability for every class.